So the next chapter that we're going to take a look at starts with a new way of going down through your program. Instead of this sequential method where you did line 10, line 11, line 12, line 13, line 14, there are going to be times where we don't want to hit every single line in a program. And in order to do that, chapter 3 talks about doing something called a decision statement, where a decision is going to be made. Now, if I move down and I see this guy right here, it's called a single alternative. And I'm looking at an example of what's called a flow chart. Okay, we could do pseudocode, which is practice code, and we're going to look at some of that in a little bit. This is one of the methods to do pseudocode. Again, it's called a flow chart. Now, the way the flow chart works is it comes down and comes into a diamond. The diamond is going to always be a question of some sort. Okay, it's going to ask a question. It's going to say if. And those of you that did the code listings, you have an idea of what's going on already. It's going to say if, and there's going to be some sort of statement. And that statement is going to evaluate out as true or false. So the syntax is nice and simple. If Boolean. Okay. If it's true, I'm going to come in and do this block of code and then jump back in and keep going at the program. If it's false, I'm going to skip that block of code. So for the first time in our programs, we may have lines of code that we never use. So true is going to come over and it's going to hit this block of code and move on. Otherwise, it moves on. Now, if you look to the right side of my page, you see an example. If average is greater than or equal to 90. Now, this statement continues. So I'm making a big deal right here, no semicolon. Because if you have a semicolon and you say, if average is greater than 90, semicolon means end that statement, this line would get executed every single time because it's just the next line in the program in this sequential step. But because this is a decision statement, this is still all one big line. So if your average is actually greater than or equal to 90, it would do what's next. System.out.println, print out a capital A. If it's not greater than 90, it skips this and moves on in the program. So the first concept we're looking at is this single alternative. The second one is a double alternative. I come in, I ask my question again. If something, if it's true, I'm going to do this block of code and move on. If it's false, I'll do this block of code and then move on. And here's an example with the syntax. If average is greater than or equal to 70, system.out.println, you are passing. Else, what if I want to do multiple things? I need to put them in braces and create a block of code. So this time in the else, I have two things. I shortened this up, system.out.println, you are failing, system.out.println, get help. Again, this guy's called a double alternative. If this is true, again, that's what I meant by a Boolean statement. This statement inside of the parentheses is always going to evaluate as true or false. If it's true, then I want to do this block of code. Since it's a single line, I don't have the braces. Else, do this block of code. Okay, so on your next test, you're going to see it, not test chapters 1 and 2, but when we take test chapters 3 and 4. Again, none of this is on the test Wednesday. You're going to get a question that says, what are the relational operators? And you started to see a couple examples of them. Here is one, greater than or equal to. Here is one, less than. Here is an unusual one. It's equals, equals beside each other. This represents equals. And you might be saying, well, why not a single equals? Because that's already used. That's a different operator for us. That's the assignment operator. X is assigned the value of 4. Okay, so that's my assignment operator. This category of operators is called the relational operators. When we take a look at it, there's 6 of them. Less than, greater than, less than or equal to, greater than or equal to, and then finally the last one is not equal to. Okay, so this is going to be on your second test. It's going to be 8 points or 4 points. I'm going to say, what are the relational operators? You're going to list them. I'm going to say, what do they do? You're going to say, they compare expressions. Now, you are math folks as well as comp-sci folks. You need to know what an expression is versus what an equation is. An expression is a statement without an equal sign. So when I say compare expressions, I come over here, X is an expression. Y plus 6 is an expression. The constant 3 is an expression. Terms for math, right? Equation versus expression. So relational operators compare expressions, and they're going to give me the result of a Boolean. So if X is 2, what does this guy become? He evaluates as? Is 2
True.
less than 3? The alligator's mouth
Yes.
equals the bigger number. Yes. Yes.
False.
Okay. Same here. If Y is 6, does this evaluate as true or false?
False.
False, right?
Do we
Good.
know what Y is?
I just
Yeah,
said
you just
6.
said it's 6.
Yeah. Yeah. So these are things that'll be evaluated in the parentheses of an if statement to give me some sort of Boolean value, either a true or a false. Ba-da-ba-ba-ba. Questions. Questions. Now you did code listings that are relevant here. Code listings 1, 3, 5, 8, 9, 10. So you have some information already available to you. You also should have some sort of skeleton written for yourself. I know some of you stole mine that I posted the other day. But what we're going to do now today is write 3 programs in our group. Okay. The first one is called calculating pay, and that includes overtime. Second one I want you to do in your groups is to ask the user for a number, and you tell me if it's odd or even. Then the third one, you're going to go back into your quadratic, and if the discriminant is greater than 0, it's going to work. But otherwise, display your answer would have imaginary numbers because solutions. Because remember, we were getting that NaN, and that was because my discriminant was negative. So we're going to add an if statement in that program then to take care of it.
Professor,
Yes,
can't the discriminant also equal 0?
it could. You are correct. So negative is the only time it's bad. Greater than or equal to. What happens if the discriminant equals 0 though? Da, 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 da. There's only one solution. It's a double root, which means my graph, my quadratic graph, comes down and touches the x-axis. It doesn't cross the x-axis. So I want to take a look at this first one before I turn you loose into your groups. Calculate pay, including overtime. Shaka Khan. Okay, so you work for a job and you get time and a half for overtime. And I'm thinking, all right, good. I don't understand what he wants me to write in the program. So hopefully this is going to help. When you're writing programs, I think it should be a 3-step process. First step, create some test data to make sure you understand the program, and then you can use it when you actually write the program. Second step is do some sort of algorithm writing, some sort of pseudocode. These names are all interrelated. and then finally type the program. That's going to become the easy part. All right. So let's see. If I want to calculate your pay, I need to know two things. What are they?
Your hourly rate.
Yeah, hours, the number of hours. Let's call this num hours. And I heard pay rate. And then we're calculating what the pay would be. A couple numbers there. All right. When we're thinking of test data, we want to make sure our program works in all cases. So I'm going to start creating some test data, and maybe you guys are going to be able to. So if I work 0 hours, but I get paid $20 an hour, how much is my pay?
$0.
0. Okay. Somebody tell me how many hours they worked last week, and you can make this up.
10.
10. What's your pay rate?
15.
$15 an hour. And what was your pay?
150.
Right. So we're getting the idea that it's just this times this. Now, thinking program, you know, all of a sudden you get a full-time job. How many hours do you work?
40.
40?
Well, hopefully 40.
Hopefully 40.
Usually more.
What's your pay rate?
22.
Everybody get a nice, honest, even value when they get paid?
$22.73 an hour.
You got my point, right? So now I'm looking at this and I'm going, okay, I think I need a calculator. So now I'm going to come back and go, well, what if I didn't say 73? What if I said 2210? Is that a little easier? Because what should my answer be?
880.
880. 884, I think. 40 times 22 is 880. 40 times 10 cents. So now all of a sudden I get an answer that looks something like that. All right. Wait a minute. What are my data types going to be for this program?
Doubles.
Doubles.
Yeah. Could you possibly work 10.5 hours?
Mm-hmm. Oh, yeah.
Yeah. Yeah. Okay. All right. So last week was a busy week. I had to work some overtime. How many hours did I work?
46.
46. What's my pay rate? How about we keep this one simple, right? We keep this one simple. Let's make it just $10 an hour. How much did I get paid?
460.
What do we get for overtime?
Time and a half.
Time and a half.
Time and a half. So I'm thinking for this program, it's going to be 40 times 10. And then it's going to be, how many hours did I get in overtime?
6.
How'd you figure that out?
Well, I subtracted 40 from hours worked.
Right. So now it's going to be 46 minus 40, which gave me the 60, times how much am I making in overtime?
15.
15.
15. How did you get that?
I multiplied rate by 1.5.
Yeah, 10 times 1.5. In fact, if I now had to make this an equation, an expression, I think I got something here. Where does the 40 come from? If my hours is bigger than 40, right? I'm going to do 40 times, where's the 10? That's my pay rate,
Pay
right?
rate.
Pay rate. So that's my first 40 hours. And then what's the 46? That's my num hours. So now over here, it's going to be num hours minus 40 times, where's my 10 coming from? Pay rate times 1.5. That's a big one. But writing it out, I'm now able to come up with a nice expression that I'm going to use in my code. I think I like all of my test data. In fact, if somebody did the algebra here for me, it looks like 400 plus 90. 490 should be my answer. Cool. So what do I do? Well, so far I've been saying what the program's supposed to do. I need to input num hours. I need to input pay rate. I know everything up here is going to be doubles. So I'm making a whole bunch of notes before I just get ready and start typing, because it's going to make it so much easier for me to just do the typing. Now I'm saying what? If I had two different ways to figure out my pay. What dictates which way? The number of hours, right? If, tell me what we got.
If number hours is greater than 40.
Okay, that means I have my overtime. And then otherwise I have, so pay is what? Well, it's going to be this statement, right? If it's greater than 40, it's going to be 40 times pay rate plus num hours minus 40, which gives me those extra 6 times my rate times 1.5. Otherwise else, pay equaled num hours times pay rate.
Hours.
And then what do I want to output? I know I want to output everything. I want to output, here's the number of hours you worked. Here's your pay rate. You know, we can make all this look pretty because all I'm doing is typing here and you've earned so much in pay. This is all going to be done with a GUI, right? Your dialog boxes and your message boxes, your input dialog.